Hydrocarbons are organic compounds made up of only carbon and hydrogen. Like you couldn't tell that. Hydrocarbons, they're the simplest types of organic molecules, and they serve as building blocks for many of the more complex compounds that we discuss. You might associate hydrocarbons with fossil fuels like oil and natural gas, but they're also found in things like plastics, fuels, and chemical solvents. Methane, which is CH4, is an incredibly simple hydrocarbon where one carbon atom is bonded to four hydrogen atoms. You can also have longer chains like fat molecules and lipids that might have 10, 20, or even more carbon atoms in a row. The length and the type of the bonds in the chain, whether the bonds are single, double, those affect how the hydrocarbon behaves. For example, saturated fats like butter have these really long chains of single bonds between the carbon atoms. So those chains are saturated with hydrogen. But unsaturated fats like olive oil, they have double bonds between the carbons and they kind of have kinks in the chain. Hydrocarbon chains are sources of energy, like these, and they release a lot of energy when they're broken down through your processes of metabolism, called catabolism. That's what breakdown means. A hydrocarbon ring is when the carbon atoms form a closed loop instead of a straight chain. And these rings can be made up of just carbon atoms, or sometimes the rings, they might have hydrogen atoms attached to them. A common example in biology is acetaminophen, or what's known by the brand name of Tylenol, which I have pictured on the bottom left there. It has a 6-carbon ring with alternating single and double bonds, and it's such a simple compound that we use it a lot in chemistry labs. The bases of DNA, and when I say that, I mean like the A, T, G, C, the adenine, thymine, cytosine, and guanine. The bases of DNA, they also contain carbon rings. And those carbon rings have certain bonds on them that interact to form this final shape of DNA, which is really a twisted ladder, kind of like a spiral staircase. A functional group is a specific collection of atoms within a molecule. And that specific collection has a particular set of chemical properties, and that collection behaves in a very predictable way. So, in simpler terms, it's like a special group of atoms that give a molecule its characteristic features, right? And it determines how that molecule behaves, how it acts with other molecules. Um, we won't see functional groups that much more in this class, but they're incredibly important when you get into chemistry and biochemistry. Yes, it is a good thing to think of a functional group like a personality, right? No matter how big the molecule is, if it has certain functional groups, it's going to behave in similar ways to other molecules within that group. I recently read an article saying that the way in which you sneeze, we think, is an inherited trait. So people in a family will most likely have the same sneezing action, right? Kind of like how these functional groups all have similar behaviors as well.